such so that we continue to bring you the best speakers and present interesting and relevant topics. If you or your organization would like to become a member, please speak with myself or one of the board members after the presentation or online. Sorry about that. BayLISA would like to thank Cisco for supporting BayLISA by arranging this space to hold our events. Please be respectful of facilities and remember to clean up after yourselves before you leave. Without support, we wouldn't be able to hold these events. So we want to make sure we're good.
Woo!
Yay!
Thank you, Cisco.
BayLISA is a volunteer organization. As such, the board is always looking for new volunteers. If you enjoy these talks, we encourage you to give back to the community and help. It's not hard work, but many hands makes the lift easier. The board meets on the first Tuesday of the month to make plans for the general meetings, discuss topics and speakers, and generally make BayLISA better. Above all else, though, we need help finding speakers. So if you necessarily don't have time to help volunteer, we're always interested to know what you want to hear for future talks and events. Maybe you have a subject you'd like to hear more about. Maybe there's a specific speaker you'd like to hear from, or maybe you have an application or project you're working on that you feel has an experience report or of interest to the BayLISA community. If any of this interests you, again, please find myself or one of the board members. And again, feel free to drop us a line on the meetup.com site. We typically reserve a little bit of time for announcements. So to start us off, are there any BayLISA board member announcements? Oh, okay. Cisco, no, we don't have Cisco representatives. Job announcements. Again, we take a few minutes to dedicate anybody who either their company's hiring or you're looking for a job. We have a volunteer.
Well, I don't know about volunteer. LinkedIn has a position open for an email administrator, a postmaster, if you will. So,
yes. Just tell me it was a risky position or something.
Is my position what happened to the last one?
Buried under
We can discuss the nuances, the potential future in such position, but there is a rec open and we are talking to people. So if you always wanted to bear the proud title of postmaster in your career, grab me.
Just restate that quickly for the people online. There's an opening for a postmaster position at LinkedIn. So if you get in touch with us on the meetup.com site, we can get you in contact with that person.
There's a system engineer role there too.
Oh, there's a system engineer role there too. So
system engineer.
Staff system engineer at LinkedIn. So if you're interested, drop a line on the meetup.com and we'll get you in contact with him. No job opening there too. Just making sure. Okay, we'd like to keep you informed of upcoming interesting tech events going on in the Bay Area and beyond. Not a whole lot going on this month. It's either happening or it has happened, but there's still in a couple of weeks. AWS reInvent starts 2 weeks from now. As of late yesterday, I still had vendors asking me if I wanted a ticket to the show. So if you can get to Vegas next week, hit up your vendors and see if they have any free tickets for you. Talk to your boss. KubeCon America wrapped up last week, but KubeCon EU is going to be held in Amsterdam this year in March. Being international, March is right around the corner. If you want to go there, there's deadlines like tickets and flights and passports. So hit your boss up tomorrow before you leave for Thanksgiving to see if they're interested in sending you. Okay, so anybody else have? Oh,
yeah. So there is a robot block party with Basil Barbecue on Saturday at Circuit Lounge, Mountain View.
Where now?
Circuit Lounge.
Circuit Launch, it's the old Hacker Dojo.
So the old Hacker Dojo Circuit Lounge.
$5.99 Fairchild.
$5.99 Fairchild is having a
Robot block party.
robot block party.
Yeah, it's a community of robot.
Okay, community of
Silicon
robot
Valley
developers.
community.
So if you are interested in ROS and stuff like that,
Physical AI.
fiscal AI.
Physical AI.
So I want to meet our new overlords. You want to meet our new overlords this Saturday, right?
So you can register on Luma.
Register on Luma.
Yeah, Luma. You can find
Luma.com, Luma.org.
Luma dot something I don't.
Well, we'll post something on Meetup. So if you're interested in robots, if something happens.
And Meetup also, you might be able to find it.
Yeah.
On Meetup.
We'll post more on our Meetup so you can find it on Meetup. Okay, before we get started, we ask you please check your phones and put them on silent and or vibrate. Many of us are on call rotations, and so we'll understand if you get paged. But please, if you have to take a call, please step outside to minimize the disruption. Okay, so building distributed systems is hard. Modern techniques can make it easier, but designing, tuning, operating one correctly is highly dependent upon a particular use case. And so one size or even many sizes do not fit all. While you can find a number of books and courses on run-of-the-mill solutions, almost all real-life implementations require bespoke solutions. Tonight, we are in luck that Intuit has chosen to share their experience and insights in building their distributed system, not with just the old, tired, and true designs, but one looking towards the ever nearer future involving observability and AI. So please welcome from Intuit, Senior Product Manager Sri, and Principal Software Engineer Derek Wang with their talk, Reimagining Event-Driven Architectures, Intuit's Journey to Serverless.
Thank you. I hope I'm audible to everyone out there.
Yeah, thank you.
So, my name is Sri. I work as a product manager on the Intuit Kubernetes platform team, and I have Derek today who's joining us. And we'll be sharing a little bit about our Intuit platform as such, some of the challenges that we have seen, observed across the board from different teams while they were moving towards an event-driven architecture. And then lastly, we'll primarily talk about the open source project that we have developed as we were trying to solve some of these challenges. And we'll show a quick demo of some of the case studies and how even the external community is actually using the product too. So with that, this is our agenda. Like I said, we're going to quickly talk about the platform, the challenges that we have seen, what is Numaflow, and then the case studies and the demo. So like majority of you might be aware of what Intuit as a company is. We are a global fintech platform company with products like TurboTax, QuickBooks, Mailchimp, and Credit Karma. Both on the consumer side and even also on the enterprise side, where we serve close to more than 100 million customers, processing more than $100 billion in tax refunds, more than $2 trillion in the invoices and across the board. And we have been a huge contributor and also user of open source. We have been awarded like the end user award by CNCF twice in 2019 and 2022. And lastly, like I just want to see like if the crowd is well aware of Kubernetes and also maybe Argo, like if you have heard about Argo CD, Argo Workflows. So Argo was actually conceptualized and then open source incubated and open source by Intuit from the get-go. And some of the learnings that we had while developing and open sourcing Argo is also coming into play with our new project called as Numaflow. So we'll be talking about all of that in our session. And then moving on, how many of you have worked with event-driven architectures or event-driven services? Perfect. So this is the crowd we are talking to. So in short, like when you think about event-driven architecture or event-driven services, it's all about reacting to as and when the events are happening. It could be from sensors, it could be from different business systems emitting events and whatnot. You're trying to react them or process them as they're happening. So if you think about it, like you'll have different kinds of sources where you are receiving all of these events from. It could be via Kafka, Pulsar, maybe from different kinds of sources like MQTT, SQS, NATS, different kinds of streaming sources where you can receive these events from. And then you're just processing those events. And then once you process them, you move it to downstream. Whether you want to use it for your reporting needs, probably you want to use it for some kind of alerting needs, whatever the use case may be. It's simply you're receiving those events, you're processing them, you're just moving it to downstream, either for data movement or whatever the needs are. But when you think about all of these event-driven applications as such, let's look at some of the real-world examples, right? Let's say you're trying to do you're placing orders on Amazon. Like what would happen next? Probably there would be some updates that will be happening in inventory. Probably your order has to be shipped. So multiple systems come into play as and when you place a purchase order on Amazon. So that's one use case that you can think of. And the second is we can think about IoT data processing. Let's say, for example, one temperature sensor says that, hey, the temperature is really high, then probably you'd want to go execute some kind of shutdown protocols and like whatnot. Think of it as predictive maintenance and some of those use cases around that. And then the third is like real-time analytics. It could be like, hey, how many users are actually browsing maybe TikTok right now or maybe Instagram right now. So all of these are done in real time. So you can think of such a use case as real-time analytics. And then lastly, fraud detection, because we operate in a fintech space. That's a constant use case that you come across. Whenever payments are happening, you would want to detect if it's a fraud real time or not. So these are some of the real like event-driven applications or use cases that you'd come across on a day-to-day basis. Like in short, you can say that event-driven systems are powering the entire application suites as of today. Moving on, like let's discuss about some of the challenges that we started observing when we were trying to move towards event-driven architecture at Intuit. So when we have seen that initial architecture, right, like where you have teams had to connect to different kinds of sources. It could be like Kafka, Pulsar, or SQS, different kinds of sources. The second is they had to focus on writing that business logic. And then lastly, when you're trying to deploy all of these applications on Kubernetes, you end up in operational challenges also, either in terms of monitoring or in terms of scaling and things like that. So the first and foremost challenge that we have seen from our teams at Intuit was that they were writing a lot of boilerplate code. Let's say, for example, like most of our streaming systems at Intuit were, one is like Kafka. We use SQS intensively. We use Pulsar at the same time. We also have other streaming sources, but when you think about developers, the constant change or the constant challenge that they had was they were writing a lot of boilerplate code. And this boilerplate code was not consistent across the board. Like if you talk about a team A, they would be implementing an integration with Kafka in a particular manner. They might be using some framework. Let's say you might be of Spring Boot or whatever. They might be using some Spring Boot Cloud Streams, different framework. And there could be another team which might be implementing applications in Python. They have their own client and everything like that. So there was no consistent pattern, and each of these implementations had inefficiencies also. They were not efficiently consuming the events from different sources. It could be Kafka. Consuming from like all of these streaming sources, one is integration part of it, and the second is efficiently consuming them. So there was no consistent patterns that we were observing. That's one. The second, like I mentioned, is around scaling complexities. Let's say if you have been operating in the Kubernetes ecosystem, the most common simple auto-scaling pattern that you use is HPA, looking at your CPU and memory. But when it comes to event-driven applications, one of the way ideally you would want to scale your applications is you would want to understand how many events are pending in your, let's say, in your queues. It could be Kafka or anything like that. Essentially, you would want to look at pending messages, or you would want to look at like consumer lag and things like that. That was not happening as a standard manner. And the way teams were trying to operate was they were trying to do manual auto scaling. Like essentially, they would either over provision their resources, keep the value always static set of pods so that they are efficiently consuming them. And that was either leading to high cost, essentially inefficient resource utilization. Think about it. Let's say, for example, on our products, it could be QuickBooks or TurboTax. Most often than not, on the weekends, you will not see any kind of a traffic. And majority of our customers are especially either in the US or in the European market as such. So rest of the times when there is actually the traffic low, even then our systems are really scaled up high because they're actually provisioning manual set of pods and like whatnot. So we were always seeing like scaling challenges either in terms of resource underutilization or cost and things like that. And then lastly, observability also. When you think about this distributed architecture where you are trying to consume events from different kinds of sources, the constant challenge or the pain point that the teams had was, hey, where is our bottleneck? Let's say, for example, if your latency of processing those events was really high, where the bottleneck was coming from? Is it because we are inefficiently consuming them? Or is it my processing logic that's taking time? Or is it me writing to a downstream, which is actually not taking that entire throughput that I'm sending downstream? So where are the bottlenecks coming from? So we do not have that end-to-end observability that we are constantly looking out for. So in short, it's like integration was a challenge, efficient consumption was a challenge, scaling was a challenge, even the observability or the monitoring end-to-end was a challenge that we were constantly seeing across the board. So that's where we came up with our open source project called as Numaflow, where we try to solve all of these pain points with the developers in mind. And we also extended our framework or our platform beyond simple event processing use cases towards stream processing use cases. So what do I mean by stream processing is like, let's say, for example, you want to do kind of map, reduce kind of aggregations and whatnot on real-time data, the windowing, aggregation, all of that. That was something that even our developers were looking for, because existing systems out there, let's say, if you're thinking about simple event processing, you can implement all of that. But when it comes to the real-time data processing or stream processing applications, the challenge was that the applications that are out there, it could be Apache Flink or maybe Kafka Streams or maybe Spark Streaming. All of these were hugely Java frameworks and JVM, and they were not Kubernetes native. And that is not something that was really sitting well with our users because we are completely a Kubernetes shop. And we were constantly seeing resiliency issues, and teams were either Python, Go, and different personas, and they wanted to write stream processing jobs in different languages, not just Java as such. So it's a culmination of simple event processing use cases, and additionally the real-time data processing use cases is where and how we actually came up with Numaflow as an open source project. With that, I would like to call upon Derek, and he's going to give you an introduction of what the platform is all about and how we are using it with some demos. And we'll also share some of the case studies set into it, and also from the community, how the community is using it.
All right. Thanks, Sri. Sri, talk about a lot of challenges we experienced in the past, and I'll continue to give you introduction about our solution, how we address those challenges, how we solve this problem. Before doing a deep dive in this project, so I want to start with the philosophy we designed this problem. So the thing we thought about was to build a serverless platform for event processing. Because as a developer, we always tend to use some sort of managed platform so that we don't need to worry about the infrastructure. And then we can focus on the things that we're really good at and the things that really matter, right? Which is writing the code for our business logic. And that is a way to improve the productivity. So to solve this kind of problem, we try to think, so to solve this kind of problem, we try to think, what's the way to abstract a platform? And the way we think of it is like, we're going to provide an abstract infrastructure so that the user do not have to worry about the infrastructure, and they can focus on the things they're really working on. Take a machine learning engineer as an example. You can imagine as a machine learning engineer, the best thing you can do is to do things like machine learning exploration experiments. And somehow, when you use a event-driven architecture to do your machine learning related jobs, you probably need to start with like a processing event from event source. And then in Elementor, you write some code to consume the data from the source. And think about machine learning, probably the best language you use is like Python. And then you have to use Python to write your event processing code to consume data from the source. This kind of thing, you will spend a lot of time for you to do it. And think about if you run this application on Kubernetes, you probably need to think about how to get your event processing system running Kubernetes reliable and secure. Right? So because this, we abstract infrastructure, so that you don't have to worry about the infrastructure. You can focus. You don't need to worry about if you need to be a Kubernetes expert to run your event processing system on Kubernetes. And everyone knows on Kubernetes, those kind of events like a power restart, node restart happens very often. And so most of the application running on Kubernetes is like a stateless, but somehow for event processing application, it's sort of stable, right? You're worried about you're going to lose some data when those things happen. But with Numaflow, we designed this system with like Kubernetes native technology so that it's resilient to this kind of power restart and node restart. And we also designed the system as a language agnostic platform so that you can use any language to write your event processing logic. This is very important. Think about it, as a machine learning engineer, maybe the most language you're familiar with Python, but somehow, if you can use different language to consume data from event source, and sometimes even you don't need to write the event, that's even better, right? So the second thing we did is we decouple the source and sinks, which means we provide this kind of popular data source like Kafka, Parser, NAS, etc., as a built-in source and sinks. So if you consume data from this kind of data source, and you don't need to write any code, just give some configuration. And it's happening if you want to send the process data to this data sinks, and you don't need to write the data sinks as well. You just to use our predefined source sinks just in the configuration. And if you want to read some data, let's say from a database, something we don't support out of the box, and we provide SDK for you easily to write to a user-defined source, similar for user-defined sink, to implement our own source and sinks. And the important thing is as long as your data format doesn't change, you can easily switch the source from Kafka to Parser, or switch your sink from SQS to whatever data store you want to use. And we also built a strong control plan to make the system scalable, reliable, and secure. We provide our own autoscaling capability out of the box. So which means we're not using the traditional CPU memory, like HK related autoscaling strategy, autoscaling, but we do QuickBooks analysis. We look into the traffic and load in autoscale, and we provide the ability to do autoscale from 0 to n, which means if there's no traffic, we autoscale down to 0. We also provide a control plane to help you do the progressive rollout, which means if you have any code change, we're not going to blindly to shut down your old event processing workload. We're going to do some analysis on your new workload, new deployment to see if everything's running well before turning off your old workload. In Numaflow, there are two different kind of abstractions for the event processing. One is called monovertex, which is super for simple event processing. This monovertex is a Kubernetes CRD, which means we put it, Kubernetes native CR that you can use it to represent a simple event processing. And this monovertex CR actually contains multiple pods. Here, the multiple means 0 to n. And within the monovertex pod, there are multiple containers. Your user code to do the event processing actually is one of the containers over there. And we have some other containers used to consume the data from data source and forward data to the sinks. And the communication between those containers is gRPC over Unix domain socket. So that's a magic we use to do like a language nesting, so which means you can use any language in your user container, as long as it's like protocol supported language. And the other abstraction in Numaflow is like we call it pipeline, which is used for complex event processing. And a pipeline contains multiple vertices, and each vertex contains multiple paths. We autoscale this kind of paths independently. So in a pipeline, you have source vertices and sink vertices, and there's another one called UDF, which stands for user-defined function, where it runs your user-defined logic. And you can come up with a very complex pipeline topology, like a graph style pipeline topology. You define all this kind of vertex by yourself. And I'm going to skip this page. I'm go direct to a demo. So I'm going to show how we abstract event processing in the code. For the demo, I'm going to do like 3-4 demos over here. So for this demo, you're going to see actually it's actually on my laptop. I have a Kubernetes cluster and there's a K3s Kubernetes cluster. Here I only have a Kafka, which is actually running Red Hat right here. I have a Kafka, and what I'm going to do, I'm going to start an application to generate some events to this Kafka. So the events I'm going to generate, so I'm going to generate some word, okay? I'm going to show you this, let me apply this management first. And then I'm going to show you what is there in this YAML file. So basically, there's an image over there. It's the word gen application, and it's pointing to the Kafka I installed in this namespace and specify the Kafka topic. Right, my topic name is my topic. And if I just look into the log of this pod, so basically it's generating this kind of word, random word, and sending to the Kafka topic. So the next thing I want to do is I'm going to start an application using Numaflow monovertex to consume the data from this Kafka topic. And let me apply the manifest first. So first, I'm going to show a UDF example. While it's creating, actually what's going on with this UDF. So in this demo, the UDF, what I'm going to run over there is this function, my transformer. This is the abstract event processing function is in Golang, but actually we provide different language to do it. You can use our language, similar function signature. And this function signature, there's one important thing is called data. And you don't see anything like a Kafka or any data store, and everything is just a data. And what do we do with this data? We get the value from data. It's a binary. And then for this demo, we know it's a string. So I just convert it as a string and do some transformation over there. So I add a hello comment to this word, and then should return it. I'm expecting with this transformer, I'm going to convert the word to something like a hello, blah blah, right? And the main function, I have a flag say, hey, if the UDF, I'm going to start this transformer. That's everything I do for this demo. So if I look at this spec, this is a model vertex I just created, and there's a source. I'm pointing to the Kafka. I just created in Kafka my topic, and the UDF is running the image which contains the code executable. I have a argument says UDF, and then after processing, the transfer message will be sent to another Kafka topic, still in the same Kafka service, but in my output, my topic output, right? So let's look at this model vertex in the UI. So we have a UI coming out of the box. So I'm going to the names of the demo, and this is the model vertex I just created. Clicking it, we're going to see this model is actually processing with the rate like less than 1 per second, which is the same as what I used to generate the word. By clicking into this slide, you're going to see the logs. I printed it in, actually, if you check the source code here, I actually printed a log in the transfer function, transfer messages, and ship the message over there, right? So we're seeing this kind of log, which means the message has been transformed and sent to the Kafka. And now I'm probably going to say, hey, how do I know if the message has been sent to Kafka with like hello, or blah, blah, right? And what I can do to verify it is like, let's say I have a second, mono vertex, UD sync. Let me update this guy. Output. So this UD sync, this mono vertex will read the data from the output topic, and then it's going to do something in the UD sync. And now, let me create the pipeline first, and then let's see what's happening in the UD sync. So the UD sync code is actually running like my sync. The function signature is very similar to the transformer. And here, the major difference is like, I'm expecting a channel of data, and where I'm going to do a for loop. And then I'm just printing out, finish the processing word, and print out the word. Here, we're expecting the word will be something like a hello, comma, blah, 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 instead of the word itself, right? So now if we go back to the UI, we're seeing the second UD sync. And if I click it and check the log in the UD sync, we're seeing a finished processing word, hello, blah, blah. This is a simple demo about to showcase how to use Numaflow to do event processing either in your user function or in your user-defined sync. And you're probably going to say, hey, if I have some data source, I want to process it, and I want to do some complex processing. Let's say I want some branch. I want to send the process message to different downstream services. How should I do that? Right? So in this case, we can use the pipeline abstraction. Let me clean up all the model works I just created, and then So for pipeline abstraction, we need to create another object for which called in the buffer service, which is provides some sort of persistent support for the pipeline, for the message transmitted in the pipeline. We're going to make sure there's no data loss for it. While it's creating, let me show you the pipeline we're going to create it. So in this pipeline, I define multiple vertices. And the first vertex is called in, which is used to read the data from my topic, which is original word I generated, still keep generating. And then I'm going to do a transformer over there, still use the same image, same flag, which is UDF, which is adding a hello comment to the word. And next, I have two syncs in this case. I have a Kafka output. I don't need to specify any image. I just use the built-in Kafka, configure brokers and topic. And then I also want to print it out in another vertex. In the end, I use edge to connect all of them from in to transformer, transformer to output, and transformer also to log output, right? This is the pipeline I'm going to get created. So takes a while to get the pipeline to create it. All right, it's running. All right. Now, if I go to the UI, I already deleted the monoverses I created before, and I only have a then pipeline right here. So we're seeing pipeline topology like this, just as we saw in the YAML file. I have in, which is reading data from Kafka, and the transformer is doing things like adding hello comment to the front end of the word. And then in the end, this one is into the Kafka topic, and the other one is to log off. If you look into the logs of this guy. So we're seeing, hey, the transformer message is hello, and the word go, right? So that's a pipeline use case. Yeah.
When it says not available, does that mean it just does not have data to show that's the throughput, right?
Yeah, that's throughput. Now it's there because it's just to create it, so it takes time to get the data coming over there. Yeah. And here, there's a number here that represents how many pods are running for this vertex. And I can show you a real production pipeline running into it. You can see it, right? So this is a real production pipeline running into it too. To do anomaly detection for the application generate metrics. So into the application will generate, this kind of common metric like a latency, error, and this metric will be forwarded to a Kafka topic. And this pipeline will consume the data from the Kafka topic and then do some anomaly detection. So that's why you see an inference vertex here. And obviously the inference will be like using Python, right? And the one funny stuff with this pipeline is like we're actually using different languages in pipeline or different vertices. So the inference is using Python, and there are some, after inference, we are doing some post-processing to normalize the anomaly score, and then anomaly score will be sent to multiple different syncs, sent to wavefront for alerting purpose, and sent to some other Kafka topic to do analysis. And this kind of sync, for example, the wavefront sync is sent to wavefront. If you look into the image, I think it's reading Go. And even before, before the inference, it is doing some sort of pre-processing to get, the metrics suitable for the anomaly detection. And also, another interesting is that in this pipeline, we're also doing some training. If the model is sort of out of date, we're going to send the data, and there's a trainer right here. If the model is sort of out of date, it's going to send to the trainer to do more training. So it's sort of complex pipeline we're running into it, and then you're seeing there are different kind of numbers on the box. So for pre-processing, it's running 2, and for trainer. Right now it's running 2, but you can see different number for different vertices.
that the number of pods you have for that one? Or?
Yeah, that is the number of pods for that one. So you can, we click this guy, you're gonna see, this represents, you can check the memory, CPU utilization, also the logs for different pods. Okay, I think that's a demo I have. And back to the slides.
Can I ask a question about this?
Yeah, good.
Sorry. I wasn't on top of it. When you started the data running first, the stream, and then you started your agent, your filter, did it see past data, or is it only going from present, present?
So if you look into this, sure. If you look at the pipeline configuration, actually we're in consumer group. So if the data actually is earlier than you start this pipeline, which means the consumer group was not there, and the data before that will be, will not be there. It really depends on, how you configure. There's a default, start offset. So I think it by default it start from the latest, but it's configurable. But once you start this pipeline, the consumer group has been established, and then it will even use pause this pipeline. You resume later, it's going to start from the position that you left. Yeah, that actually reminds me. There is some other interesting feature on the UI that. So, for example, for this pipeline, you can do some operation. For example, you want to pause the pipeline. You pause it, which means you're going to do something. For whatever reason, you want to pause the pipeline, and you're going to see the pause will be terminated. The original vertex pause will be terminated. And if I resume it, it will start processing, and the pause, this pause will be recreated 4 seconds. Right? That's that. Yeah. Back to the slides, and somehow trying to connect. Anyways, I can just go. Let's do a quick recap about Numaflow. So it's a Kubernetes native service platform for running scalable and reliable event-driven applications. Here, Kubernetes native does not really does not only mean we're running Kubernetes, but also utilizing Kubernetes native feature to build the platform. And it's very lightweight. And a lot of our external users are actually running Numaflow in their edge device, even without having internet access. And it's a language agnostic platform. Technically, you can use any language to run your user function, source and things. We provide SDKs in those popular language, Java, Python, Golang, Rust. We're working on the TypeScript support to provide TypeScript support as well, SDK as well. The any language support. And we have many built-in source and things, so you don't need to write any code to consume data or send that to this data store. And we have autoscaling feature out of the box, makes it a sort of cost effective, right? Very lightweight. Capable of running edge devices. Yeah, I think I'm gonna hand over to Sherif to cover the internal use case and external user.
Thanks, Derek. So far we have seen like Numaflow as a platform for developing event-driven applications and even writing stream processing jobs, right? In any language that you like. Like when you saw that entire pipeline that is running in production, which had some of those steps written in Python, Java, Go across the board. So when you think about your team, let's say if you have your entire, you are working on some anomaly detection pipeline, ideally what would happen is in the anomaly part of it would be written by your ML team. That's like your entire Python infrastructure. And then probably the pre-processing steps might be written in like Java or maybe Go based upon your team's tech stack and whatnot. All of the entire teams can come together instead of using different platforms and anything like that. They can come to one platform. They can write any of those processing steps in any language that they like and then execute what are the functions that they want to do. It's like one-stop shop for either you're a developer or a platform engineer or an ML engineer or anyone. If you want to do real-time event processing or like stream processing, you can definitely use Numaflow as a platform. So now moving on, like I just want to cover some of the case studies that we have. Like one case study I'll share about is like how QuickBooks is using Numaflow at scale. And then I'll also share some of the case studies from external and how the community is also using Numaflow. So a lot of you might be aware of QuickBooks. QuickBooks is primarily used by a lot of small and medium enterprises to manage their books, accounting, payroll, and like whatnot. So QuickBooks was going through this entire modernization journey where they're actually breaking these capabilities into, or the entire monolith into small capabilities. Different. Let's say, for example, accounting is going to be its own capability, payroll is going to be its own capability, and like different kind of architecture as such. But when you have these different distributed multiple capabilities as such, you would also want to have integration layer as well, where you want to move or have some kind of integration between your QuickBooks accounting with your payroll. Let's say you have a new customer that's joining in accounting who also needs payroll. Like you can just actually send out all of these events on the onboarding to accounting, payroll, and across the board. So you're using this entire event-driven architecture to integrate across the different products as such. So they're going through this entire modernization journey of like breaking into multiple capabilities, moving into an entire event-driven architecture. So some of the challenges that they had were, like I said earlier, one is integrating with Kafka, inefficient processing and all of that was going on. The second is like they had to operate at really high scale. Like some of them could vary anywhere between like 1 billion events per day to multiple billions per day in processing. So, and some of the results that we have seen once they started moving to Numaflow was that earlier all of their applications were implemented in like Java and they were just deploying on Kubernetes. But once they started moving into Numaflow, they started seeing a lot of operational benefits primarily. One was in terms of processing times of all of their events. Like they saw close to 60x improvement in terms of TP95, where let's say, for example, in the beginning, I think it was some of the events were taking like close to 25 seconds at the TP95 value. But towards the end, like once they started adopting and all of that, the entire processing latency dropped to like 420 milliseconds. And the majority of the chunk was primarily coming from the inefficient consumption from Kafka and the way they have written their integration as such. That was one. And then the second was autoscaling was not working as expected. The second was, like I said, autoscaling was the biggest reason for that too. And then lastly, the autoscaling also saved them close to 40% of the entire cost that they were bearing so far. And the reason for that was, like, as I said, most often than not, they were always had static set of pods, always scaled up throughout the weekends, even then when there was no events flowing in or traffic was flowing in. But with Numaflow, they can absolutely scale down to 0 if need be when there is no traffic coming in. So you have that autoscaling capability from 0 to n based upon the throughput that you're receiving, at what rate you're processing, and at what rate even your downstream is consuming those events. So we consider all of these as a end-to-end queue-depth analysis and then autoscale all of that. And then lastly, they got the entire observability. Like I think Derek didn't get a chance to show you some of the observability features that we had. You saw only the logs part of it. But let's say, for example, if I just go to pre-processing or any of these steps, we provide these out-of-the-box metrics also, like the pending messages for that one particular vertex in itself, and what is the processing time latency, read latency, what is the entire processing time, all of that. All of these metrics are broken down right from read, acknowledgement time, processing time, writing down to downstream to any kind of sync. So when you have such kind of a breakdown, let's say when you have any kind of latency, it's much easier to pinpoint saying that, hey, is the latency coming from like the platform? Where is Numaflow causing the problem, or any integration is causing a problem, or is it the processing that's taking time, or is it the sync that is actually not able to consume all the events you're sending downstream? So when you have that clear breakdown, it helps a lot of time for the developers to pinpoint and go efficiently fix any of those issues. So that's the added advantage that they got in terms of the insights.
Can you show the on the latency, like
The metrics? Oh yeah.
like want to expand?
Yeah.
UDF, like examples. So is that like start to finish for the UDF or?
See, there's this is very less 3.919 millisecond. This is the just the read processing time. Yeah.
And this is again real time.
Yes.
And inbuilt observability.
Yeah. Inbuilt within the platform itself.
Nice.
Yeah. And you can actually, if you want to use Prometheus operator and then send all of those metrics down to any of your other systems, you can definitely, or if you want to emit any kind of custom metrics, you can do that too.
This is anywhere with the in-cluster Prometheus. So the measure coming from Prometheus actually.
Oh, okay.
But the metrics were generated by Numaflow. Permits the script those metrics, and here this
In the
this
UI.
UI.
So the actual metrics goes to the Prometheus and then it's kind of a dashboard.
So this is part of baked into the platform itself. But if you look at it, it'll only give you for a short window. So one of the biggest learning that we actually got for this was actually from Argo. If you look at any of the developers, most often than not, what they used to do is they used to deploy their applications and look at the logs from Argo CD immediately. So they like that feature of looking at real-time logs. So we took the inspiration from there and then brought the logs and even the metrics as well, so that the teams can look at real-time what is happening. But all of these metrics, we send it downstream to our internal observability platform and everything, so that for longer retention, alerting, and rest of the pieces. So this is for like real-time debugging that will definitely help you. And you can look at all of these at like each pod. Like for example, that particular step had 2 pods, so you can see what is the like CPU utilization, memory utilization per pod within the UI end to end. So that was the other advantage that the teams had. Earlier, they never had the visibility into where that lag was coming from, why the lag was coming in, and all of that. So they were able to process, yeah.
So when you say independently scalable, so how does it, before it wasn't, and with the
So now with respect to Numaflow, like you can clearly see here, right? You have 4 pods that is for your input vertex where we are consuming the events. The second is like has 2 pods, and then you can see on the inference side it has 3 pods, and then post processing it has 2 pods. So the way we do this scaling per vertex is we understand how many events you are receiving in this buffer or the step before that, and we understand at what rate you are processing them. And in order to consume all of these events that are in and process all of those out, how many pods do you need? And then automatically we scale that. So essentially across the entire pipeline, we do a queue depth analysis from right to left. So we understand for each step where we are seeing a lot of backlog, we immediately scale that step out so that you'll be able to process those events immediately and then send downstream. If at all, let's say, for example, you're writing to a database, it's not able to keep up, or maybe your database is completely down, then the back pressure will kick in all the way such that it will stop consuming from Kafka. So you don't have to worry about like stopping the pipeline or stop consuming or anything like that. Everything is done for you within the platform. So like the back pressure will kick in all the way till and say that, hey, I cannot consume anymore because my sync is down. So that's like, those are the additional benefits teams tend to see. And we also have implemented other features. Let's say, for example, DB maintenance is most often than not that we tend to see. So sometimes what teams would want to do is they want to write to some kind of a dead letter queue, like where they have another sync that they have configured called as like a fallback sync. So essentially when this sync is down, they'll write automatically our system will route those events into the fallback sync or a dead letter queue, which you can again consume back later on and then process them again. So we give that feature.
Along those lines, can user manually specify I like queue in this parts to throttle or to control the flow?
I didn't get the second
Well,
part.
so I guess when I'm thinking of your auto scaling, for example, do you always scale so that you always have a unit available to X to process every event that is arriving? Or could you potentially say, I don't need this process right away, I could have it queued for a while and because a little spiky and I would have average it out over time?
Yes.
You
So
have that kind of feature.
we have something coming up very soon, what we call as distributed throttling. That will be, there are 2 ways to do it. One is you can actually configure within the existing pipeline we have some features called as read batch size and some of those pieces where you can configure how many events you want to consume to start with. That's one way to solve for it. But some of these pipelines lately, what we are observing is especially on the LLM side of things. Let's say at Intuit, some of the teams are creating these pipelines for running agents. So essentially they consume these events and there is some agent logic running in one of those steps. And then finally they output it to downstream. But when the agent logic is considered, it's essentially making a bunch of LLM calls to downstream. And they are always throttled when you're making those requests. So we are introducing a feature called as distributed throttling. The way it would work is basically you can configure and tell that, hey, I only always want to process X number of messages so that you don't break your downstream. Because some of the downstreams may not have all the resiliencies and everything in place. So you can definitely control the throttling if you want to within the pipeline.
Let me add something. So basically, what you can do is for each vertex, you can have your approach to tune the auto scaling strategy. You want to get it faster to go up, or you want to slowly to go down, or just kind of thing you can tune for each individual vertex. And that's one thing. The second thing is Sri mentioned, distributed throttling, which means for each vertex, there actually you can run multiple pods, right? So you want to do some throttling across all the pods for one vertex. That is something you can control. That is all.
So these were some of the benefits that one specific team that actually saw at Intuit, but we have more than 600 odd pipelines running at scale at Intuit, solving for different use cases, right from simple event-driven services to doing inference on streaming data to stream processing, and even now all of the entire agentic buzz that's going on, where teams are running event-driven agents or asynchronous agents where they're consuming events and doing some kind of agentic logic and all of that too. So, and the primary use case for agents was that if you look at some of these latency of processing of those agents, it's like per event, it could be based on the use case, it could go anywhere between like a couple of seconds to more than a minute if need be. So when you are going to more than a minute in terms of processing, you cannot have synchronous kind of agents. Rather, they want to move to a complete asynchronous pattern. So that is where we are seeing a lot of uptick of using Numaflow, where they want to run these event-driven agents or like asynchronous way of running AI agents too. So that's another use case that's completely coming up new, even within Intuit and even externally at the same time, based upon the processing latencies and whatnot.
So, so the pipeline, the processors could be between GPUs and CPUs.
Yes, that's a very good point. So that is where you will actually see this on the open source community. So these are the broad use cases. I'll touch upon all of them, but answering to your question on this is around the AI ML inference. NTT team is actually using Numaflow pipelines in that way. So what they do is, if you go back to the pipeline in here, for the inference step, ideally you would want to need some GPUs. And then probably for pre-processing and post-processing, you don't need any kind of GPUs. So what they're actually doing is, because our platform is completely Kubernetes native, for the pre-processing and post-processing, you just give CPU as resources, but for only inference, you give GPU resources. Essentially, what they're doing is they're accelerator chaining. They're using CPUs plus GPUs plus CPUs as a chain of accelerators. And they have a use case where they're exploring, and they actually presented at KubeCon North America last week.
Who?
NTT Labs,
Oh.
and the way they're actually chaining GPUs, I think even FPGAs, so different kinds of resources, because like you can we support DRA, so for each of these vertex you can specify what resources that you want to use in the spec itself. So that's the added advantage that you have with Numaflow. You can specify for vertex level resource consumption, whatever you want. So that's the specific use case that like NTT team has been using Numaflow for. And broadly touching upon, if you look at, maybe I'll try to see if I can the slideshow this. So on the open source side, not just Intuit, you have a lot of other companies exploring using Numaflow. I'm only mentioning some of those people who have officially added themselves as to the users list, but there are a lot more companies who are actually using Numaflow on the open source side. So some of the use cases that you would see is broadly in these three categories. The first is like IoT and edge data processing, where teams are deploying these Numaflow pipelines on edge devices, either to do IoT data processing or radio signal processing. And some of these devices are completely cut off from internet. They run it on Minikube or K3D, small Kubernetes clusters, run this fire and forget. And the pipelines are always running. If at all they will have to update these pipelines, they literally have to bring the devices back and then manually update all of the pipelines. So it's completely very low footprint edge data processing is where we are seeing Numaflow. So some of the companies that are using is like Lockheed Martin. They use it for IoT data processing. Bumer Group is actually very interesting. They process, they are into supply chain primarily for conveyor belts and all of that. They look into audio signals of all the conveyor belt wheels in order to understand if they are dislodged or misaligned or things like that. So that's a very interesting use case. They do audio signal processing in order to figure out if the conveyor belts are working as expected. And then B-Cubed, they're into radio signal processing. So all of these are very low footprint edge data processing use cases where they use Numaflow for. And coming to the AI ML inference, like I said, Entity is using it for accelerated chaining. And then Seeker is like one of the platforms. I think it's a ML platform company where they use it for processing a lot of text data and even audio data, where they have these ML pipelines constantly running. And lastly, you can see a lot of real-time intelligence where teams use it for either fraud detection, alerting, monitoring.
Security.
There are a few more companies I definitely didn't mention here, which have not officially added, but they use it for network monitoring and then even some supply chain related monitoring and things like that. So they have different kinds of use cases is what we are seeing on that front.
In IoT, did you mention any MQTT?
Yes. B-Cubed, I believe they actually have MQTT source.
Can you do the use case? Do you remember?
I cannot divulge a lot more because these are specific use cases from the companies, but they're primarily into like radio signal processing and things like that. So these are some of the use cases on the community side, but broadly you'd see if I have to pick and choose, teams are using it primarily for stream processing use cases and language agnostic reasons, and then very lightweight and low, like very lightweight stream processing platform. I think these are the three pieces why it's resonating with the teams. Most of them actually reach out to us saying that recently one of them actually wanted us to implement, or they were asking for like, hey, do we have a C# SDK? Because like writing stream processing jobs in C# is not something that you would see any day, but Numaflow is the only platform that could potentially support C# for you to write stream processing jobs. And we actually spoke to another one today in the morning. They wanted to use Numaflow because they were migrating their existing pipeline from Apache Flink. They wanted to migrate because of cost. They were running into really high cost, and then the JVM taking a lot of resources, specifically when they are deploying at scale and prod for high throughput. And they are exploring Numaflow using Python to see if it would reduce their costs. So you see, like they want to do stream processing in different languages. They want to reduce their costs. They want to have a reliable system on Kubernetes, low footprint, and things like that. So yeah, so here are some of the use cases and how the community is using.
Anyone uses it? What is the most used language there, and also any use cases with Node.js?
That's a good one. At Intuit, we use a lot of Java and Python based upon the teams. If it's application developers, they use a lot of Java. If it's ML teams, they'll have to use Python. On the community, we are seeing a lot more adoption on Python. And then comes maybe Go, and then along with that, probably Java as well. So these are the two things. And then in terms of language support, I think we are starting with the next one is going to be the TypeScript. So that's what we are going to support. And supporting for another language is not really hard for us because we use the binders, right, from Rust.
Yeah, we use protocol for script. I mean, the protocol is protocol. So every SDK language support their unique same interface. Just use the protocol for the general implementation in that language, and then do some utility function to make the SDK easy to use.
Okay, got it. And go ahead.
Yeah, I think we are pretty much towards the end. I mean, if you are interested in the project, you can definitely scan the QR code. You'll find the GitHub repository. You will also find our Slack channel if at all anyone is interested to join and then ask any questions. Definitely try it out. Yeah, sure.
I was another tricky question. So what about errors and debugging and testing? And what happens if one of your processors crashes, or either intermittently or constantly? How would you deal with that?
Yeah. So when we think of errors, there are two layers to it. One is at the platform layer, and the second is the application code layer itself. let's say if you have issues in the application code, and if you're not able to process any of those events, we keep retrying infinitely. And we can also configure how many times do you want to retry and all of those features too. And at the application layer, if at all there are any issues, we definitely log all of that. You can export all of those logs into your existing systems to try to debug as much as possible. But if it's an application layer thing, you'll always see all of those logs in the UI itself. So you can definitely look at them in the UI and then see, okay, what is the issue and all of that.
So a couple of questions. So Numaflow was developed with the Go.
So the controller and all of that is still on the Go, but the core data plane where that takes care of the data movement and all of that, it's written in Rust. Earlier it was in Go. Now
So that's why you claim it's a lightweight and faster than the Kafka.
That is one of the reasons. We say lightweight it means you actually we think about some other event processing or streaming data processing system. Most of them are in Java stack, right?
Like Kafka.
No, I'm not talking Kafka, but let's say Flink or Spark Stream, this kind of text system. They're actually Java based. If you want to write your own data processing jobs with this kind of platform, you need to use Java to do, or Scala. Anyways, Java, Java ecosystem, and there's no other support. Maybe Flink they support some sort of Python, but it's not fully.
No, not native Python.
Yeah, so that's the common pain point for a lot of data engineers. They don't want to Java. They don't want to use Java, but they have to use Java, and they don't have some sort of language system to do it.
One part is definitely Rust. Does bring in that efficiency of like low resource usage and all of that. And then the second is like a lot of it is not Java intensive, because JVM generally eats up a lot of memory. Even today, like I said, in the morning we had a conversation with one of the open source community member who was interested in adopting Numaflow. The reason they were trying to migrate from Apache Flink to Numaflow was that the amount of resources that they were provisioning for their JVM, especially for the Flink job, was just like skyrocketing based upon the throughput that they were seeing. So they wanted to see, is there any way we can reduce those costs and like whatnot? That's where they were trying out. We saw some of those benefits at Intuit also when we started migrating some of the simple pipelines as such. We saw like close to 30% of cost reduction, like right off the bat. So
yeah, for this kind of system like Flink or Spark Stream, it's not something that can be easily installed in Kubernetes cluster. And usually even in Intuit we are running Flink in our Stream clustering platform, but we have a large team manage the entire system. It's very heavy. There's no way for you to run this kind of system in, let's say, on edge devices. There's no way to do it. And
so, is there a minimum cluster requirement?
I mean, for Numaflow, you can't say no, because you see our demo. I did it actually running on my laptop. It's just a K3s cluster. It's not a full feature supported in Kubernetes cluster. Just K3s, like Minikube or Kind. And a lot of edge devices they're actually running K3s.
What about RabbitQ instead of Kafka?
I'm sorry.
Well, I want something like RabbitMQ instead of Kafka.
you can, we don't have a support for native RabbitMQ yet, but if at all you want to write a source that is going to consume from RabbitMQ, we can definitely write it, because all of our SDKs are there. We have a source interface or a user-defined source interface that we can implement, follow the semantics of the user-defined source, and we can implement. So that's what we have seen. Let's say, for example, one of the, I think it was, if I remember, it was BCube or someone. They had a different queue called ZMQ, if I remember correctly. Yeah, they implemented their own user-defined source to consume from ZMQ. So
the reason we didn't implement this kind of queues because it's not used in Intuit. So
No. Well, the interface to be able to.
Yeah. So if you want to implement your own source, you can use. I mean, using one of this SDK to implement a user-defined source, but technically it could be implemented as a built-in source or sync.
Okay. Thank you. No Perl support? No Perl support?
it's all open source.
Yeah, we are not. See, one of the things here, so we're not trying to sell this product. Intuit has its own way to make money. We are not just it's open source product.
And I mean, we definitely learned a lot from like Argo days, and that is also driving our passion to contribute back to the community more and more as and when we are developing something that's like agnostic to anyone that could use it.
How supportive is Intuit of you open sourcing this?
I think we have made big strides with Argo primarily. I think that is where we started our journey. Like within Argo, you have multiple projects from Argo CD, Argo workflows, Argo rollouts, and across the board. So even Argo, like there are more projects actually. Like let's go past this.
It's a huge feature.
Yeah, I think.
Yeah, one thing is like we do not open source for open source. We actually use it a lot in Intuit. For Argo, that's the same thing. We open source Argo because Intuit has a lot of requirements using this. I'm sorry. Yeah. So I just mentioned that we do not open source for open source, which means when we work on this kind of open source project, we internally we also use them a lot. Argo is the same situation that we use Argo a lot internally, and similar for Numaflow. And we actually we're not trying to sell this kind of thing for money, but for internal we have better support, that's for sure. We have some drag and drop experience to create this pipeline for just right now it's for internal.
And the other aspect of like open sourcing definitely helps us in terms of tech branding and even tech talent. Let's say, for example, if we see some of the, we have seen really good contributors on Numaflow, even Argo and all of that. So it definitely acts as a channel for us to even attract talent back into the company too, and find the right talent because they understand our infrastructure, they understand problem statements that we are working on. So that's like a straight fit for us to get some of those folks who are actually working on some of those problem statements that we are just putting out there too. So that's another way to look at it if you want to. Awesome. If anyone interested, you can definitely scan the QR code. You'll find the GitHub repository for our project. If you like our presentation, definitely give us a start our project, or even join our Slack channel, and then happy to answer any more questions. Thank you. It goes to our GitHub repository.
Oh, okay. It's the URL.
Goes to Bitly first.
Where's your slide?
It's
You can find it in GitHub repository.
It's in the GitHub.
yeah.
Cool. Thanks.
Great talk. So we can start getting all your pipelines organized and streamed. So I'm curious, why did you call it Numa?
I think
Flow? Because Numa has a definition of
It's memoryless stuff.
Yeah. non-uniform memory access.
I think it actually comes from
so there are multiple theories that are actually running in our team. One of the theories that if you think about Kubernetes, the entire cloud native ecosystem, you'd see a lot of references to the water. Essentially, if you look at the Kubernetes, it's the wheel of the that you see on the ship, and the Docker similarly, and all of that. I think there's a subtle reference of Numaflow in some Greek literature related to water, and even our logo is actually a polar bear. So, yeah.
Coca-Cola's been dramatic for that.
So is there any, I mean, how do you use it with the robotic data stream with the entity?
How they use it?
For the robotic stream?
I'd say like we are completely agnostic to any kind of source. Let's say if you're running it on Kubernetes and if you can write, if you're not able to use any of our out-of-the-box sources, if you're able to like write your own source, there's nothing stopping you from using Numaflow as such.
Yeah, so basically data moving in the pipeline, we don't care. We don't touch data at all. You can use any format you want to use. You can use XML, YAML, JSON. We don't care. Just, because we don't touch it. So you understand what kind of data format you're going to use. It's purely data agnostic.
And that's what you'd observe even in terms of use cases. Some of them are using it for IoT data processing. There were actually people who were using, I think this has been like maybe 2 years ago. They're actually a huge manufacturer, like automobile manufacturer from Japan. I cannot name them. They use it for processing some of their map data. So like they chunk the map data and then process it for different use cases that they have. So you'd see from simple IoT data processing to map data processing to like financial data processing and across the board. And we have seen like very even recently we started talking to another one on the community. Apparently they process information about ships, like where you have all of these real-time information about all of the ships and the commodities that they carry, and they process that information and they sell it to hedge funds so that they can trade on commodities and things like that. So that's like for not exactly high frequency trading, but mostly hedge funds trading about on commodities and whatnot. So it's like they need the real-time data to trade it. So those are some of those use cases that we see: financial, like IoT, and then industrial across the board.
And it sells to pirates too, right?
I think that definitely helps.
It's a side hustle.
Yes.
I need the real-time data. The real.
Okay, thank you again very much.
Thanks for using VBA there.
Thank you everybody for coming. Thank you everybody online for watching. We're trying to get something together for next month, but maybe not. December is always a hard month. So just in case we don't see you, happy holidays, happy New Year, and
Wow.
see you next time. We might not see you in case we don't have a schedule. December's always hard. So down there.
Great. It just reminded me of Serverless. So.
You put all that.
No, I